Welcome to this talk about Megacity on mobile and how we optimized it with adaptive performance. A new feature in Unity which we developed in partnership with Samsung and their Samsung GameSDK. I'm David Berger. I'm software developer at Unity Technologies. I'm working on the mobile team. I've been with Unity about 5 years, working on optimizing customer projects, like from indie development, indie projects to AAA productions, to everything. So I got a good kind of experience on like what our customers want and need from mobile titles. With me on stage today is Jungwoo, and he's principal engineer at Samsung, and he's going to talk about the Samsung GameSDK. There we go. The stage is all yours.
Hi, I'm Jungwoo from Samsung. I read the GPU and also the game dev in Samsung Mobile, and want to talk about a little bit about the game SDK Samsung is now developing and working with the Unity for adaptive performance support. So mobile, there's many kind of limitations. One of the biggest limitation is coming from the form factor differences. So even the Note 9, that is the biggest form factor in the smartphone, but it's a much higher, much lower, the smaller form factor is not in between even the smallest, the desktop form factor. Also, we are keep chasing the hardware to allow more power and performance, but the progressing doesn't not always faster than PC and desktop, and also the chipset size, you can imagine that how much differences could be. Also, we are even chasing the peak performance, but the peak performance not always we can use always. So that is not, in considering the sustainable performance and power that in the gaming, then even we reaching to the PlayStation 3 or 4, but that does not mean we are delivering the same experience with the same performance. So optimization is really important, and because that we think that fundamental improvement is required based on that new technology. So optimizing the game experience, there's the two kind of approaches. One is optimizing the device itself to deliver the good experience and support the resources enoughly to cover the game performance. Another one is optimizing game itself to helping more better API and driver, and also more good editor and more better engine library to deliver the more faster processing or something. So we are considering not just the device side, but also the game side optimization. And we also consider then how we dealing with not just one device or the game, but how we can work that device and game work together. Let's talk about a little bit in the governor in Android or iOS, like the mobile device in UI rendering. So most of the UI rendering is interaction model. So as the people touching the display, and then the workload is generated high, and then animation go, then the workload is degraded gradually. So the governor in most of the mobile devices is now working with that. So the yellow graph is the frequency, and blue graph is the workload. Then the first responding timing, there's some latency then made that the response lately happen, performance drop happen. But most of cases now in the Android devices now supporting the touch boost, that the event happen, then the boosting the frequency in initial time, that is the covering that late response issue. But in the gaming, the governor is a little bit unexpectedly behavior. So the workload in the gaming is happen not even without any interaction with the user event, but also each of the frame by frame, the workload is generated. So it's something like it's shaking, and this type of the wave workload pattern is keep continuing. So the governor is working like this. So it late a bit right after the generation of the workload that hitting. And then some bad thing happened after that. So the rate response happened, each of every frame by frame. And after that, frequency is going high, but the workload is gone. Then every frame by frame, there's some overreact happen. So frequencies don't necessarily increasing higher than. And then that is consuming a lot of power. That also hurt the performance, and also heating problem will happen. So if we consider we just cap the frequency maximum in the application side control the device, then that rate response performance drop might be happen, but that is not that much of heavy, and may overreact is not that also that much of heavy. Then you also can. Oh, sorry. So you also can not consuming that much of high performance power consumption, but also you don't have to worry about losing the performance. So in the heating management perspective too, so most of cases people are trying to reaching to the 60 frames per second first, but the temperature is going high, the throttling happen, then the performance is dropped down significantly, and then after the 20 minutes after that, the performance is lower than the 40 frames per second also. If we just consider that targeting not 60 frames per second, but the 50 frames per second, then the temperature is not that much of the highly increasing, but you can steady keeping that 50 frames per second ever. So the GameSDK we designed with the covering this type of issues, and we deliver the on high temp warning, so you can know when that the temperature is going, and also that when the throttling happens. And you can react on each of every signal for the warning level 0, 1, 2 to do work on something on your application level. And also you want to monitor the trend of the temperatures going high, and then we deliver the temp level like the abstracted from the level 0 to the 7, and you can monitor the trend, and then also the application do something react on that. About that, the cap the frequency maximum also handled by the set level within API that is delivered. You can control the maximum frequency of your application will use. Then you don't have to overreact, and your frequency is marginally managed by your own performance. So GameSDK is something delivered the way of the interacting application and device. And this allows more things you can control explicitly and also correctly. So Samsung is now doing the Galaxy Game Dev, and we have the many experiences with working with the game developer, and voices we gather from the developer is something they really want to control things more precisely. So we are delivering both and 64-bit multi-thread rendering, but at the same time try to deliver the GPU watch-like tool and also the GameSDK like SDK API set. So because this type of SDK, including the low-level API, may the developer have some hard to use it, or may developer can do the wrong thing, and that makes some situation worse. So we decided to work with Unity to bring this more correctly on the ecosystem. Adaptive performance is that. So David will cover more about the adaptive performance.
Thank you. Thank you very much, Jungwoo. So this is a pretty amazing thing nowadays, because that actually means until now we had no possibility whatsoever to react on thermal events on mobile devices. And as we heard, that the Samsung GameSDK now actually makes it possible to react onto those changes. So we work together with Samsung to make sure to improve their GameSDK and integrate it within Unity, so that we have a good connection on Samsung devices. And that means now that we essentially have the possibility to very easily obtain device performance status and thermal events and thermal trends as well. So that means for game developers, they can now proactively adjust performance and the quality settings on the fly during runtime in the game. So this is pretty amazing for mobile devices. So this means that you basically can concentrate on figuring out what the thermal trends are and the status on the device, and then get maximum quality as well as maximum performance, and throughout get smoother gameplay or viewer experiences throughout the whole game with more stable frame rates while having a lower energy impact. And this is like something which is super important in mobile games, right? Because essentially you want to have your players play for longer while having less impact on the energy consumption on their device. So to test adaptive performance and the implementation we did, we took Megacity and implemented adaptive performance to see if it can make an improvement when it runs on the new flagship device, Galaxy S10, which is our reference device for adaptive performance. Why Megacity? So Megacity is a giant streaming world project which we just unveiled last year and released this week for desktop platforms. And it's a great demo project for mobile as well, because we basically push over 8 million triangles onto the GPU. We have more than 6 million singular entities in the whole game world simulating at once. We do have more than 2,000 cars in the mobile version, over 100,000 audio sources which need to be mixed and played. And everything is basically dynamically streamed in and out. And you might imagine that this is a very, very hard thing for mobile devices to actually get that right at a stable frame rate. So to showcase what is possible with adaptive performance, we tried to do this. And one of the things we tried to figure out is it possible to run stable 30 FPS over time, or if we have the same problems as before. So what's the status before? This is Megacity running over 20 minutes, targeting 30 FPS. So you see in the graph, it just continuously goes down. If there are thermal events happening, the frame rate is going to drop, and at some point the game cannot cope with, or the device cannot cope with the game anymore, and we go into throttling state, which we see at around 15 minutes in the game. So this is essentially what we try to avoid, right? So the idea is that we're going to start with a low CPU and GPU level in the main menu, because in the main menu there is not much going on. When we go into the actual game mode, we start increasing the CPU level to cope with all the loading going on in the game. And then increase the GPU level and CPU level depending on bottleneck within the game. This should make sure that we keep the energy consumption low, but get the highest quality within the game. Another thing we do is, if we're not hitting the target frame rate, we're going to decrease the LOD bias. So this is going to decrease the GFX load, triangle, memory, draw calls on the CPU as well as on the GPU side. And one other thing we also do within the game now is decrease the target frame rate when we are close to throttling. Because you can imagine, if you want to avoid that the device actually goes into the throttling state and you cannot reach that by all the previous states, you have to take some other action. And in our case, we lower it to 28 frames per second. So the big question is now, did it actually work? And I'm here telling you about those things. So yes, it does work. We see still the red line of the previous run, and now with adaptive performance on, the blue line, we see that we have a more stable 30 FPS over a way longer time during runtime. So even after 60 minutes, which is way in like all the very heavy parts of the game, we are still maintaining 30 FPS. And only after we get thermal warnings and would go into throttling, we drop the frame rate to 28 FPS and gonna maintain that throughout the game. So one of the things which happened was, when I tested one of the new builds from Samsung, it was kind of very late, so I kind of forgot that I had the game running. And the next morning, when I came back to my machine, the game actually was still running on the device with stable 28 FPS. So it works over 10 hours without any degradation in FPS. So we kind of proved that within Megacity, it actually does its job very, very well. So let's have a very good look how this actually looks like. We're going to see on the left side is Megacity running on the Galaxy S10 with adaptive performance turned on, and on the right side, adaptive performance is turned off. So in the beginning of the game and the run, we're going to see that the quality is very similar. The performance is very similar. We are at 30 FPS. And then over the course of game, the device heats up. We're going to get thermal events. So in this case, we see there are still all the cars there. The LOD is very similar. But then at some point, we're going to get thermal events. And in the thermal events, we raise the CPU in this case because we are CPU bound. This means we're going to drop very quickly on the adaptive performance side. But overall, in the further progress of the game, we see, like in this scene, that we are keeping the 28 FPS, while on the version without adaptive performance SDK, we drop to 22 frames per second. And the game actually never can recover from that. So without the performance SDK, we never go over 20 FPS, except it's a very, very low detailed scene. While the differences are that the LOTs are gonna pop a little bit more on the adaptive performance side, there are a little bit less cars, so it kind of depends on what your game is about. You know best what to increase, what to decrease to actually maintain the performance you want to maintain. And with adaptive performance, you now finally got like the tools to actually do that. You get the events, you get the bottlenecks, and yeah, within Megacity, for example, lowering the LOD is not that big of a problem because we have so much detail in the scenes that it actually doesn't really affect the visual appearance, at least. It does affect so far because it's a mobile device, so the LOD bias is already kind of low anyway, so the popping is increased. But this is like just a demo project to show off adaptive performance and not a design project. So whatever you're designing, you have full control over what you actually want to do. And that's one of the very important parts for us. Because when you add the adaptive performance, it's super easy. It's one click in the Unity package manager and it's installed. If you deploy it to your device at this stage, it's gonna report the status of the thermal events just to the console if you opt in and if the device is supporting that. So the thing is, we ship adaptive performance as low-level API and as high-level API. The manager is made in a high-level API sense. So if you don't like what we offer you, what we do, then you can completely throw it away and do whatever you like with the low-level API, which is a good point to start. But if you want to use the managing instance, it's super easy to use because you basically just add one script to your scene, you catch the adaptive performance manager, and then you subscribe to, for example, the thermal events or the bottleneck events. And in this case, this is from our menu scene in Megacity. We set the CPU level and the GPU level to the lowest level, which means GPU is running very low frequency, saves tons of energy, and we can run longer. So then when we go into game, we're gonna raise those things. We also subscribe to thermal status changes. This means when we get a throttling imminent event, it tells us, well, you're gonna have problems on your temperature, so you might wanna do something against that. And in our case, we're gonna lower the target frame rate to 20 FPS. And then if you would go into throttling, which with adaptive performance in Megacity at least, we never go into throttling, we could set it even to a lower frame rate, but the device kind of does already the throttling events for you anyway. And then you also can subscribe to performance bottleneck events, and those are essential because they tell you now if you're GPU bound, if you're CPU bound, or if you're target frame rate bound. And what that helps you to do is, if you're GPU bound, you can raise your GPU frequency or the GPU level. And respectively, this is also happening on the CPU. If you realize, well, this is a heavy start, we are CPU bound, you raise the CPU level. And otherwise, you also can decrease the CPU level to save energy again. Or in cases where this might not be possible because you already have the higher level, and we, in the Megacity demo, just lower the LOD bias. And if you're target frame rate bound, that kind of means you reach your target frame rate anyway, so you can start, depending on if it makes sense or not, to lower the CPU level and the GPU level again to save power and battery, or to raise the LOD, in our case the LOD bias again, to increase the quality of the game. So you see, it's very easy to implement, it's super easy to react, and you have full control over what you actually can do when you get those events. So what's next? Basically, adaptive performance is going into preview, into preview on the package manager in the upcoming weeks. And I hope you guys can try and provide us feedback if it all makes sense the way it is, or whatnot. So, but this is only basically to kick off all the events. As said earlier, we are partnering with Samsung and work very, very closely to make the API on their side rock solid. So it's very, very sustainable and usable for game developers to use. Right now, we use the Galaxy S10 as reference device. But coming next is also we try to get it onto the Galaxy Fold, and over the next couple of months we're gonna roll it out on Galaxy family devices as well. So millions, or a lot of devices in the players' hands already are available, and you can ship it to those very easily. So the preview itself is gonna run on 19.1. We're gonna go into verified states in 2019.3. That doesn't mean we stop development. That basically just means we have way more time to actually go in full support, add more features, add more high-level features, and gives us the opportunity to actually improve the product. And for all the future changes, everything 2019.3 and beyond, we plan to have like adaptive components for your game, so that the designers actually can tweak the particle effects based on the adaptive performance areas you have. So should be a very easy approach to implement the changes without any coding knowledge, if this is needed for your development. So that's it for now and for today. There are a couple of minutes left, I guess, for questions. So if there are any, please bring them up. Otherwise, reach out to me at any time. I'm super happy to talk about anything Unity related. And as well, I'm on the booth after probably 1:30 until the end of the show today, and also tomorrow. So if there are any open questions, please hit up. No questions? Okay.